All right, so let's look at the simulator and learn about it a little bit. All the directions are given on the lab manual, so if you follow the step-by-step instruction correctly, you would not mess it up. All right, so the first the version that we're using is the interferences. So click on it and it will open you to a simulator like this one. So we're going to use the laser light. So click on the laser light. Now you can change the colors, and when necessary, we can use it as a single slit or a single source or a double source. So here we can change the amplitude. So the simulator is automatically setting it to the green color, but you can change the colors if necessary. And then you click on the graph, and then you can get the screen. Actually, let's take a screen so we can look at the patterns on the screen. And then if you click on the intensity, you can see the intensity graph over here. So it's a the laser light is an electromagnetic wave, as you know. So you can draw the electric field variation over the time or the length, right? So here, also we need to make it to a slow motion, and let's pause the simulator so it won't start automatically when you switch on the laser light. And also we need a timer to measure the time it takes the wavefront to travel. And let's make it run. So when you switch on the simulator, it will start counting the time, right? So here in the first step, you're going to use the, actually you're doing the first part is the interference of waves, and you're using a single laser light here. So we're going to switch on one of the lights and let the wavefronts create the fringe pattern. Now here on the screen, you can see the fringe pattern, and on the graph, you will see the intensity graph, right? So let's switch this on. So I'm in the slow motion. If you mess up any of the settings, you can refresh the simulator and restart again. All right, so let's play. Of course, I need to switch on one of the laser light, and then I'll play. And I'll wait until the edge of the waveforms come closer to the screen and touch the screen. Not okay. So let it run. Here you go. And I'll go slowly until it's touched the. If you can do it for the first time, it's okay. You refresh the simulator and restart. Okay, so that's now it touches the screen. So at that point, I'll stop running the simulator and I'll read the time from here. And also, as you see, the bright fringes are here. Those are the bright fringe that I mentioned earlier. So you may count the number of fringes over here, the bright ones. So here, 1, 2, 3, 4, 5, 6, 7, 8, and 9 wavefronts are there. So in this part of the experiment, you're going to change the colors and observe the variation of the number of fringes and the time in this case. Also, you can take a graph if you like to see the electric field variation. And if you want to measure the sizes, then you can use the ruler to measure the size. Let's say I want to measure the wavelength. So I will use the ruler to measure the wavelength. So it's a peak to peak height, right? So I will use the peak to peak and measure the wavelength of the light. All right, now let's say we are switching to the next part of the experiment. So I need to refresh the simulator again and get the laser light. And I'm keeping green light, that's fine. And the separation of the two slits are about 1,500, that's 1,500 nanometers. Please follow the instruction on the simulator. Maybe I ask you to change the size, maybe not. So if you want to change the separation of the two lights, you may do that as well. And then I need a timer maybe. And then I need to pause the simulator for a second, and then I switch on both lights, and then I need a screen to see the variation, and also I need the intensity graph. Maybe in the previous part, we don't need the intensity graph to observe, but in this one, when we are using the two slits, we will be using a screen and a graph, so we can analyze it a little better than what we did earlier. All right, so now let's run the simulator and wait for about 50, let's say until the waves reaches to the screen and create a fringe pattern nicely in there, bright and intense. Get that. So when the light reaches to the screen, it creates a nice fringe pattern over here. And you can observe the intensity graph variation as well. So one places we have a maxima, other places we have minima. So minimas are representing the dark fringes and the maximas are representing the bright fringes over here. So this is a double slit. So as I mentioned earlier in the theory, so you see these bright fringes in the screen, right? Now, if you change the colors to red, then the separations will be different as well. So you will be doing the experiment for red, green and the blue light. So you will be seeing like how these fringe patterns are varying according to the wavelength of light. Now, let's say you want to measure the wavelength. So you measure it from peak to peak. So I'll keep one edge of the ruler to the one peak over here and I extend it to until the next peak. So that way I can measure the wavelength of the this intensity graph, right? The distance from peak to peak. Now, let's change it to the red light. And I'll wait until it's developed the fringe pattern here nicely. All right, look at that. Now look at the peaks are not anymore closer like earlier. This has a higher wavelength, so it's changing things. So even you can change the intensity graph focus, so you can see it better. Anyway, you should be able to compare these fringes for according to their light. I mean the color you were using.